All right, thank you. Good morning. I'm the last of this first set of three briefings from the National Labs. My name's Scott Olivier, and I'm the new NA22 representative from Lawrence Livermore. I just started in this position a couple of months ago, although I've been at Livermore for 25 years or so now. Most recently, for the last 4 years, I've been managing our Office of Science portfolio at Livermore, and so now I'm excited to move over and manage this more applied but very important R&D portfolio for our laboratory. You've already heard some of the work that's going on with students at Lawrence Livermore, and I will give you a summary of that at the end. But I did want to just orient you and show you where we are with Livermore and what we do writ large at the laboratory. So we're over here on the West Coast in this cluster of national labs with Lawrence Berkeley, with SLAC, and with the smaller of the Sandia campuses, which is right across the street from us at Livermore. The Secretary of Energy, Secretary Moniz, has pushed in the last several years for the Department of Energy National Laboratories to work more and more as a team of laboratories, as a system of labs that serve the nation. And I think that has been going forward and is seen in this portfolio, in the NA22 portfolio, with the rise of larger venture projects, multi-lab projects. And again, coming from the Office of Science, that's also the standard way of working together on science projects in that community as well. So I'm really excited to continue to do that and work with our laboratory colleagues and with universities. So this is just a picture of Livermore. We are a fairly large laboratory. We have about 6,000 employees and a budget of about $1.5 billion. So there's a lot of activity on this 1 square mile campus in Livermore and with the Sandia site just across the street. And we focus on a broad area of nuclear security, international and domestic security, and energy and environmental security, all underpinned by our disciplines in science, engineering, and computing, where most of our 3,000 technical staff sit and support those programs. For nuclear security and the stockpile stewardship program, we have these elements shown here from the annual assessment of the viability of nuclear weapons to extending the life of those weapons, upgrading them in various ways, looking at fundamental science of nuclear weapons, and then what's called here responsive tools, which is where this NA22 portfolio sits, looking at how to respond to nuclear incidents, how to limit nuclear proliferation, and how to respond to counter the threat of nuclear terrorism. So for those of you who know about Livermore, these are sort of our signature facilities at Livermore: big computers and big lasers. Okay, and so the Sequoia computer, when it came online a few years ago, was at that time the largest computer in the world. There's a few that are bigger than it now. But high-performance computing is one of the ways that we simulate and model the performance of nuclear weapons and other applications. And so this is one of our signature areas of research at Livermore. And the other thing we have is the biggest laser in the world. And so that allows us to do high energy density science investigations in the absence of nuclear testing, as we know. This is a way to reach temperatures and pressures that can validate the codes that are then used to simulate nuclear weapons. So in the other two areas that I showed on the earlier chart, domestic and international security, we are split into these areas: chemical and biological counterterrorism, intelligence activities, explosive security, and cybersecurity. Those are our main thrust areas in that portfolio. And then finally, in energy and environmental security, we look at everything from natural gas futures, renewable energy solutions, climate change and adaptation, and smart grid systems. We have a large multi-lab activity, 7 national labs involved in the next generation of modeling and simulation for large climate circulation models down to the kilometer scale over the whole Earth in terms of being able to model in climate and climate change. So again, that relies on high performance computing and is an exciting area of research at our laboratory. Let's see, so all of those programmatic activities are underpinned, as I said, by the scientists, the engineers that work on these areas, and they maintain, those discipline organizations maintain our core competencies in S&T, and these are our 7 core competencies as we currently list them, from high energy density science, advanced materials and manufacturing, bioscience and bioengineering, nuclear, chemical, and isotopic science and technology, lasers and optical science and technology, earth and atmospheric science, and high performance computing, simulation and data science, which really underpins all of these areas. So as Lieutenant Colonel Miller mentioned yesterday, our support to the NA-22 office is split into these 2 sub-offices, proliferation detection and nuclear detonation detection. And so our portfolio in that area is split. In each office there are sort of 3 distinct areas, which again Ben Miller touched on yesterday. So for the proliferation, the material production detection, we have some projects, representative projects listed here. Our total portfolio in both of these sub-offices totals about close to $60 million last year. And so the percentage I have here is just the percentage of that amount that is spent, costed in each office currently. And we have about 50 projects across the office. And I've shown about 1/3 of them I've called out on these 2 charts here. In proliferation material production detection, we have activities looking at how to detect processes in facilities that might be enriching or converting nuclear materials. In the nuclear weapons and material security portfolio, these are the projects that are largely blowing things up in the desert in Nevada and monitoring the signals, and so we have some large projects there. In non-proliferation enabling capabilities, we have a number of different projects, from looking at correlated data fission to science-guided scintillator discovery, and that makes up a good fraction of our portfolio. In the nuclear detonation detection area, we have work in space-based detection, a small activity looking at verification and validation of the U.S. system for space-based nuclear detonation detection. In the ground-based area, we have a long-standing project understanding waveform signals from ground-based nuclear detonations. We also have a large portfolio of new projects like the low-yield nuclear monitoring project, which is trying to advance the state of the art. These are actually executed out of the proliferation detection office. Now, I sort of group them here because sort of scientifically they fit in this area, but that's a large and growing part of our portfolio. And then we have a nuclear forensics set of activities out of the nuclear forensics office in this nuclear detonation detection office. So finally, the summary of the research. You've already heard talks about most of this, or a lot of this work this morning. We have 2 graduate fellows, Anthony Christie and Julie Schnur, from the University of Hawaii, who work in the infrasound group there, and so you've already heard some of this work there. Julie worked on the analysis of air blast that she already discussed this morning. Anthony Christie worked on aggregation analysis of distributed sensor measurements. We had an undergraduate fellow, Emily King, from the University of Michigan, who worked with one of our physicists, Stefan Friedrich, on the development of a metallic magnetic calorimeter for a high energy resolution gamma spectrometer, about 10 times the resolution of germanium. And then we have a collaboration in the work on correlated fission events, where one of our physicists, Ramona Vogt, received the National Scientist Fellowship from CVT to come here for a period of time and work on those activities. So finally, there are a number of activities beyond even the work that's in the NA22 portfolio in rare event detection, in fundamental data, and in nuclear forensics, just to name a few, where we're always looking for students and postdoctoral fellows to work in these groups. Really exciting areas of science that are directly applicable to the R&D portfolio in this area. And so if you have more questions or any questions about this activity at Livermore and how to get involved, we're really excited to be part of these consortia here at Berkeley and the other at North Carolina State. And the point of contact moving forward for all of these consortia is going to be Stefan Friedrich. He's currently been serving as our point of contact for the Berkeley consortia. He was here yesterday. Today he's giving a talk at another university in Michigan that I won't name. But he's excited to continue to be the point of contact for these consortia moving forward. And of course, you can always talk to me. Thank you very much.
And using existing literature, we've identified a set of 8 different factors that we believe contribute to this motivation. Now here I've listed them out. On the right you can see a funnel plot that shows the relative importance of each one of these factors as we've ascribed.